All right, now we are moving on to explicit formulas, 5A, day 2. So let's get right into the learning goals here. I can write an explicit formula when given the recursive formula. So this I mentioned in our last video. So we're going to go into more depth here. And then apply the recursive formula to a real-world problem to find a solution. All right, so let's start with the explicit formula. Once again, just to kind of get it to stick, an is the value. So it's the value, it's not the term number, it's the value of the term you are solving for. A sub 1 is the first term, n minus 1, where n is the term number in the sequence you are solving for, and d is the common difference. Okay. I'm going to keep throwing that in there as long as it's part of these targets to get you to remember that. Now the recursive formula is slightly different. It uses the same pieces though. So a sub n, that's the value of the term that you are solving for again. So what they mean don't change. What it looks like does. Okay, notice how this is now a sub n minus 1. Okay, so this isn't something that you do mathematically. And what that means, it's the term, and that should be previous, pardon my spelling, previous to the one you are solving for. So like if I was solving for, let's say this was let's say I was solving for the 13th term. This would be a 13 minus 1 or 12. Okay, so it's always going to be one less. And you're going to know one of these. And then plus or minus d, where d is the common difference again. So it's going to be plus if your common difference is positive, and of course minus if it's negative. And then you're going to have this little bit added in here where a sub 1, that's the initial term value. So whatever that first term is, that's going to go there because you need to know that. Alright, so let's take a look at the first example. We will need to write an explicit formula given the following recursive formula. So we've got an equals an minus 1 plus 4, and we're told that a1 is 16. So let's go ahead and fill in what we know. We know that this and this are the exact same thing, 16. Okay? And you can tell from here that the common difference is a positive 4. So remember, when we're just writing a formula, we're not actually solving for anything in it. This is, again, going to go straight down. And because this is plus 4, we're just going to add the 4 on the end. If this was minus a number, again, like I said yesterday, this wouldn't be a 4. This would be in parentheses and then negative whatever that number was. Okay, second example. This one's a bit more involved. Lockers line the hallways of most schools. Your favorite math teacher, me of course, hides a prize in one of the many lockers. To locate the prize, you have to open every third locker, beginning with locker number 23. Okay, so that's important, locker number 23. After some time, one of your classmates locates the prize in locker number 320. Okay, and here you have to know that you're opening every third locker. So how many lockers did your classmate need to open? So basically, opening first is number 23, and then every third locker, so 24, 25, 26 would be our second locker. And then 27, 28, 29 would be our third locker. 30, 31, 32, you get the idea. Okay? So how many do we have to open before we get to number 320? Well, we're going to start with our explicit formula. And remember that we started with 23. Okay, and we know that the prize was in locker number 320, which is why that is there. We know the common difference. What we're trying to solve for now is this. Okay? Because we don't know which locker, which number in the sequence that was. We know that the value of the term was 320. Now we need to find out which number in the sequence it was. So like if I had 1, 3, 5, 7, while the value of this is 7, this is the fourth term in this sequence. And that's what we're trying to find here, is which term number is locker number 320. Okay, so n minus 1 is just going to stay down because n is what we're trying to solve for, and that minus 1, we can't separate it from it just yet. But we do know that the common difference is 3 because we had to open every third locker. So again, we're just going to be solving for this variable. We can't do anything inside the parentheses, inside these grouping symbols. So what we have to do is go outside and distribute that 3 to each term. Even though it's on the back side, we still do it the same way as if it were on the front. So 3 times n is 3n, and 3 times -1 is -3. This right here will trip you up if you're not careful. Remember that you're multiplying these two numbers together, 3 and -1, to get this -3. Okay, now what we can do, yes, you can do these two separately, this 23 and this -3, but it's much easier to combine them on the right side of the equation first because they are like terms. So we're going to rewrite it as 20 plus 3n. Then we'll subtract 20 to the other side, which will give us 300 equals 3n. And then you'll divide both sides by 3 to get 100 for your answer. So your classmate had to open 100 lockers